Hi everyone, Avner from Logic Wiz is here, and we have an interesting puzzle to solve today. In a previous video, we have explored the fistomorph ring, which showed how two seemingly unrelated group of cells actually share the exact same digits. Fistomorph ring is rooted in math set theory, and today we're going to take it up a notch. We're going to try to solve this puzzle using set theory. Without set theory, this puzzle probably requires a long and tedious forcing chain to solve it, something that no Sudoku solver likes to do. You can try it for yourself by pressing the link in the puzzle description. The link opens the puzzle in the Logic Wiz Sudoku invariant app, which is available on both Android and iOS. Let's dive in. So first, the puzzle rules. We have 4 variants in this puzzle. We have the palindrome, which is the blue line, and basically digits on the palindrome have to be symmetrical, meaning if we have 1 here, we have to have 1 here. If 2 is here, 2 is here. We have the killer variants, which are the dotted cages, and the digits in each cage have to sum up to the digit at the top left corner without repetitions. We have the greater than variant, which are those signs, and the digit on the wide side has to be greater than the digit on the narrow side. And we have the crop key, and we have only one crop key dot here. We have here only the solid dot, which basically means that the digit in one side has to be 2 times the digit in the other side. You have to figure out which side is which. Let's get going. Okay, I'm gonna start by applying set, and I am going to mark these 2 cones, and I'm gonna paint them in blue. I'm gonna take this cone and I'm gonna paint it in blue as well. And then I'm gonna take these 4 rows, paint them in purple. Okay, what do we have now? We have now basically 4 groups of purple, which include the digits 1 to 9 each. And we have 3 groups in blue, which have the digits 1 and 9 as well. We can remove the digits which are shared between the 2 groups. Those are basically the digits with both colors in the cells. Those are the obvious ones. So let's remove them. Okay, now we remain with the exact same digits in both of the groups, and we have in addition the digits 1 and 9 in the purple cells. However, we have more digits which are shared between the groups. Those 2 digits equal to these 2 digits. Let's remove them as well. And the same goes with these 2 and these 2. These 2. And these 2 are identical. And we have also on this palindrome, the digits are identical. Let's remove them. Okay, what do we have now? We have now 12 cells in purple and 3 cells in blue. The purple cells must have these 3 cells and in addition, the digits 1 and 9. This is how we built it. This is how we started. Now, let's get going. Cage of 17 must have the digits 8 and 9. Let's fill it in. 3 must be 1 and 2. 16 must be 7 and 9. And now after we have here the 7 and 9, the 14 cannot include the 5 and 9, must be 6 and 8. We have here also 7 and 9. And in the 12 here, we can no longer have the 3 and 9 because the 9 is taken here. We cannot have the 4 and 8. We have here 5 and 7. Okay, now we know what sort of are the 3 digits that we need to have in addition to 1 and 9 in the purple cells. 8 and 9 must be twice in the purple cells. And either 5 or 7 must be twice in the purple cells. Let's look at the cage over here. It can no longer be 1 and 7 because of the 1 and 7 here. It cannot be 2 and 6 because in the purple we have only 1, 2. We cannot have 2. So the 2 is 6 is gone. We wouldn't be able to make this decision without the set theory. So these 2 cells must be 3 and 5. What else can we do here? We have now in purple 1 and 2, 3. We are missing 4. We are missing maybe 1, 5. We don't know for sure yet if this is a 5 or a 7. We have already the 6. We have 8. We are missing 1 additional 8 here. We have 7 and 9 and 1, which is either 7 or 9 here, so we need another, maybe another 7 and for sure another 9. Let's look at the cage over here. It cannot be 1 and 8 because of the 1 here. It cannot be 2 and 7. It cannot be 3 and 6 because we cannot have additional 3 and 6 in the purple cell. So 3 and 6 is gone. And this one must be 4 and 5. Okay, let's look at this row. Well, 8 and 9 can be. 8 and 9 cannot be here, therefore they cannot be here. 8 and 9 must be in these 2 cells. And therefore 8 and 9 must be here. Okay, let's look at this column and see where 7 can go. 7 cannot go here because this cell is identical to this one and we cannot have 7 here. 7 can definitely not go here. 7 cannot go here because this cell is identical to this cell and we have here 7 and 9. 7 and 9 cannot go in these 3 cells, so this cell must be 7. And this cell must be 5. Okay, we said that we need additional 8 in the purple cell. The 8 cannot be here. The only place that the 8 can go now is here. So this one is an 8. And this one is is a 3. Let's look at this cage. Now cannot be 1 and 8. It cannot be 3 and 6. 3 and 6 are taken. Okay, let's look actually at this cage. We have the 5 already taken here. We cannot have additional 5 in the purple. This one must be 4. And this one is a 5. Now we cannot have 4 and 5 here because 4 is already taken and 5 is already taken in the purple. So this one must be 2 and 7. Now 2 is taken, so purple one cannot be 2. It must be 7. Now this one is a 9. And this one is a 7. Okay, the digits which are missing here are 1, 2, it's 3, 6, and 7. And of course we need to have here 3, 6, and 7 as well because of the palindrome line. Now 3 and 7 are already taken here. This one must be a 6. This one must be a 6. Now, where 6 can go in this box? It cannot be here, not be here. It can be either one of these two cells, but we have here 7, 8, and 9 already, so 6 cannot be here. There will be no greater digit than it. So 6 must be here. And now this one is an 8, this one is a 6. Okay, the same logic with the 5 applies here. 5 cannot be here because there will be no greater digit to be on the other side. This one must be a 5. And now this one is a 3, this one is a 5. And the remaining digits here are 3 and 4. This one must be a 4. This one must be a 3. And now on the palindrome, we can set this digit to 7. And 3 goes here. Okay, well, 7 can go here. It must be here. It cannot be on this side of the crooked dot because it cannot be twice any digit, and no digit can be twice 7. Therefore, 7 can go here. This one is a 7. Now let's see which digits can go on this side of the crooked dot and on the palindrome line. It cannot be 1. Actually, it can be 1, because 2 can be here. So this is 1. It cannot be 2, because 2 is already available here. It can be a 3. It can be a 4. 5 cannot be on a solid crooked dot. Cannot be 6, 7, 8, or 9. So only 1, 3, and 4. Which basically said this side can be, because of the 1, we can have a 2, because of the 3, we can have 6, because of the 4, we can have either 2 or 8. And these are the only 3 options. Excuse me, only the 3 options over here. Okay, now which digits must go here? So obviously 8 is one of them. Okay, which digit can be here? Cannot be 1 because of the greater than. It can be 2. It cannot be 3. It cannot be 4. It cannot be 5. It cannot be 6. It cannot be 7, 8, or 9. This one can be only 2. And now, this one is a 1. Here we have 1 and a 2. And now the only remaining digits here are 7, 8, and 9. Nine cannot be here, so this one is 7 and 8. Therefore, this one can be only 8 or 9, but 8 is already here. This one must be a 9. Now this one is a 7. This one is a 9. And here we remain with 7 and 8. Okay, which digits we are missing here? We are missing here 3, 4, and 5. For here we are with 4 and 5. And here we can have 3, 4, 5. Now we removed 1 from here. I can remove it from the other side of the palindrome. 1 cannot go here. 1 here cannot be in the middle. It has to be here. Here we have the pair 1 and 2. For 1 must be here in this box. Okay, 1 cannot be here. If it cannot be here, it cannot be here. Therefore, these 6 cells cannot have 1. This is the only option for 1. And we have 2, must be one of these two cells. And what do we have in these 3 cells? It is 1, 2, and 6. Which basically set also these 2 cells to 1, 2, and 6. 7 can go in one of these two cells. Let's look at this palindrome. It cannot be 1, it cannot be 2, it cannot be 3. It can be a 4. It cannot be a 5, it cannot be a 6, it cannot be a 7, it cannot be an 8. So here we have 4 and 9. What about these two cells? It cannot be 1, it cannot be 2. It cannot be 3. It can be a 4. It can be a 5. It cannot be 6. It cannot be 7. It cannot be an 8. And it can be a 9. This can be a 4. Here, one of these two cells must be 3. We must have a 4 over here. Okay. The 4 cannot be here because of the palindrome line. Therefore, in this book, the 4 must be here. So this one must be a 4. And this one can no longer be a 4. And now here, the only option is 4, because it has to be in the middle cell of row comp 2. This one is a 4. And this one is a 4. Now this one is a 3 and a 3. This one must be a 5. This one on the palindrome must be a 9. Now this one becoming an 8. And a 9. What do we miss here? 1, 2, 3, 4, 5, and 6. Oh, this one must be 6. And a 5. You can remove the 6 from here. And what do we miss here? 1, 2, 3, 4, 1, 2, and 5. 5 cannot go here because of the 5 here. Therefore, 5 must be here. Now this one must be a 2. This one is a 1. This one is a 1. 6. 2, and because of the palindrome 2 here as well. Now 1 goes over here. Now we have the 7, set 8, set 7 remains here only in the cells in this box, because we cannot have 7 here or here. This one is a 7. Now 4 goes here. Four goes here. What do we miss here? 3 and 6. 6 cannot be here because of this 6. This must be a 3. Okay, now 3 must be here. And we are missing here 1 and 2. 1 cannot be here. This one must be a 2. What do we miss here? 1. 1 must go here. Here we already have a 8. This one must be a 9. This is basically cracking the puzzle up. I hope you enjoyed it. And so how we can apply set theory to solve a puzzle. It can be a very powerful tool. Need to do some exploring on which rows, columns to apply it. You don't always have to apply it to rows and columns. We'll do a separate video basically explaining the set theory in depth, because it's very extendable and can be used in many ways. Hope you enjoyed it, and we'll see you in the next one.